Hey everybody, I'm going to be covering the mean value theorem. If you want to follow along in your book, I'm going to be on pages 211 to 216. Okay, the problem is you're in a car traveling on an exit ramp and you go 500 feet in 10 seconds and your average velocity during that time period is 50 feet per second. And we're going to go over how the mean value theorem proves that somewhere in that average velocity time of 50 feet per second, your instantaneous velocity is also 50 feet per second. So somewhere in there, your instantaneous velocity equals your average velocity. Alright, let's go on the paper right now. I'm going to draw out the graph of f of x to be the displacement as you exit the freeway. Points A and point B are two endpoints, our beginning and the end. A secant line can be drawn between them. It touches both A and B. The secant line represents the average velocity, which is given by f of B minus f of A all over B minus A. As we plot the point C, C is the one point where the tangent line touches our graph. This tangent line is parallel to the secant line. Therefore, the slope of our average velocity, our secant line, is equal to the slope of the instantaneous velocity, our tangent line. Now, there are a couple rules to the mean value theorem. First of all, f must be differentiable for all values of x in the open interval of a and b, which means everything has to have a derivative except a and b. A and B don't have to have derivatives. However, the second rule is that f must be continuous for all values of x in the closed interval a and b. So even the endpoints have to be continuous. Therefore, at least one number between a and b, which is x equals c, is that f prime c equals f of b minus f of a over b minus a. Now let's go over a couple examples on where the mean value wouldn't work and where it would. This first one right here has a cusp in between A and B. Now since at the cusp that value is not differentiable, this one doesn't work for the mean value theorem because everything in between A and B has to have a derivative. This second example shows A not being continuous. So one of the endpoints is not continuous, and the second rule says all the points have to be continuous, so this one doesn't work. This one, although it has a cusp, is okay because the endpoints are continuous, and that's where the cusp is. It's continuous, but the endpoints don't have to be differentiable, such as this one. So here, the secant and the tangent line of this graph are parallel. Alright, let's try an actual problem. Let's say that f of x equals x to the 1/3. Plot that out right here. Let's prove the two rules of the mean value theorem work for this problem, and then find the tangent line at x equals c that's parallel to the secant line connecting A and B. First, let's find the derivative of our original equation, which turns out to be f prime of x equals 1/3 x to the negative 2/3. Now, our whole graph looks differentiable for the whole thing except possibly at 0. 0 looks like it might be a vertical slope. Let's test it real quick. Put in 0, 1/3, 0 to the negative 2/3. 0 to the negative 2/3 equals 1 over 0 to the 2/3 equals 1 over 0, which is infinite. So it doesn't work. But that's okay, because we can have the endpoints be not have a derivative. They have to be continuous, which they are, because we see that the limit as x approaches 0 and x approaches 8 are 0 and 2 respectively. Alright, now that we've proven the two rules, let's find x equals c, where the tangent line is. First, let's find the slope of the secant line, which we wrote down as our average velocity equation, f of b minus f of a all over b minus a. Alright, we'll put in our numbers. 8 to the 1/3 minus 0 to the 1/3 over 8 minus 0 is equal to 1/4. So that's the slope of our secant line. Now let's put that slope in as f prime c. So 1/3 c to the negative 2/3 equals 1/4. That goes to c to the negative 2/3 equals 3/4 after you multiply that 1/3 over. Divide the third over. And we end up getting plus or minus 1.5396. But since our entire graph is positive, we use the positive value. Now we'll do some fancy algebra. Plug our c value into the original equation. F of 1.5396 to the 1/3 is equal to 1.1547. Plug that into our mx plus b equation. Solve it for b. And you get 0.7698. We put that onto the original graph. We see that our secant and tangent lines are parallel, despite my crude graph. Alright, now I'll hand it over to Justin. Alright, good luck you guys. See you on Wednesday.